Let's further discuss what this data virtualization really is. It should fulfill these three major points. One of that is data management that allows an application to, this application refers to the consumer, to retrieve and manipulate data without requiring to know how formatted at source and how physically located. So as a consumer, we should not worry about or do in some work depend on the source, depend on the how it is physically located. And this data virtualization layer should provide us a single customer view wherever the data is, irrespective of where the data located, irrespective of how data is stored and what format. So we always, as a source, as a client, would have a single customer view out from that virtualization layer. And the second major point is real-time access is given to the source system. So this is very important. Whenever data is changed at the source, the data is real-time available to the consumer. This is very, very, very important in an enterprise architecture. The information should be available as soon as it is there in the source. So it would reduce data errors. It will reduce workload of moving data. When we don't process at on time, then it piled up and would severely affect the decision making in an organization. On the other hand, the source system does not attempt to impose a single data model. So it is important that we in an enterprise architecture, we should not attempt to have a single model everywhere, but instead this data would be in the source wherever best possible way that that particular source could handle the data. There's no single model here, but as a consumer we should be able to retrieve in our preferred way. And third point is writing of transaction data updates back to the source system. That is also very important. Now, for example, if we retrieve some data and we think when we process the data, we find out that that data should be changed and we are authorized to do so. What should we do? We should be able to communicate back to the source system, please change this data. If we don't have that facility, what would happen is the source would be somewhere else, but we have some change data which is not reflected in the source. If it takes time to do that update, again it will be kind of not matching the enterprise information architecture where you have data now in two places having different versions. So this solves differences in source and consumer formats and semantics. So there will be different formats that we would have data in different parties. For example, some systems might consider date of birth as to represent some age of a particular client, a particular person. But similarly, some other system would like to have it as age, not as the date of birth. So therefore, there are different formats or semantics would be there with different stakeholders. So this, when we update the source system, we should that update should be in one single format where the source is preferable at. But as a consumer, we might communicate in our own format. So the virtualization layer should convert that to the right format. So it is convenient for the both parties, the source and the consumer. But data virtualization does the magic to do that conversion. Right. Now, when we look at data virtualization, we see several responsibilities. One is connect. Obviously, it should connect disparate data from any source. Should be capable of connecting to any data source. It might be Google Sheet. It might be a database. It might be a API. We don't know. Tomorrow there'll be some new application built into the system to handle some data. So we should connect to that as well. So therefore there could be different sources that data virtualization layer should connect to. And after getting that data in, it should be able to define data transformation and combinations with those data. So this will bring in some valuable information to the consumers. So you get, for example, if you access to HR system, we get some information like attendance and so on and so forth. And some other system would be there where it would actually manage that particular person's project, the project schedule and so on and so forth. Now, if a manager wants to see why this particular delay happens in that project, whether there's any match with his leaves and things like that, that is kind of a combined information view the manager would like to have. So there could be that kind of combinations done at the level of data virtualization to bring in certain proper view to the consumer. And lastly, data virtualization should be able to publish that data, that information out. So this will deliver data in real time through many channels. From the data virtualization level as well, the consumers would differ in different channels. For example, one consumer would be like to connect as through via ODBC, or one would like to connect via API, or one would like to connect in different other way. So the data virtualization layer should be capable of providing those facilities as well for the consumers. So this is one of the examples. We will go through one of the examples. So that is the best way of understanding this is really about. So I have taken data virtualization as an example here. You could see this has connected to different data sources: data warehouses, enterprise applications, cloud, XML, Excel or fat files, big data, PDF, docs, emails and things like that. And when the virtualization layer gets that data in, it has some processing done to actually combine this data, and then it publishes that out for the consumers. So you could see some other facilities also available where caching and security and governance. So this is very good place where centralized security and governance to be placed, because you have access to all the sources and you can control it. And you can cache it as well, which would actually not load the below data sources, but it would provide faster response to the stakeholders or consumers.